In the last video, we defined the basic scaffold that makes up a steroid molecule. In this video, we discuss cholesterol. Cholesterol gets its own video because it's the most important steroid in the body, and it is the building block of the other steroids, such as testosterone and other hormone molecules. Interestingly, as a fun fact, gallstones are a ball that's comprised of nearly pure cholesterol. Cholesterol, although sometimes getting a bad reputation within the lipid profile when the cholesterol is too high, performs many essential functions within the body, including it's a component of the cell membrane that is essential for the structure of the cell membrane and holding the cell together in the proper form. It is also, as we mentioned, the precursor for synthesizing other steroid molecules that act as hormones and carry messages throughout the body. Taking a look at cholesterol to remind us of the structure meets the definition of a steroid because it has our set of 4 fused rings, which I'm highlighting here in pink. And those 4 fused rings, 3 of which have 6 carbon atoms here, here, and here, 1 of which has 5 carbon atoms and they're fused together in this specific form, are modified as so, with a hydroxy group here on the A ring, methyl group here, and this aliphatic non-polar, in other words, carbon chain here with a branch out here at the next to the last carbon atom. So where does cholesterol in the body come from? You might be thinking to yourself that meats high in cholesterol are the origin of high cholesterol, and that by declining those types of foods, you can dramatically impact your body's cholesterol levels. Well, that can have some effect, but it's not necessarily the be-all, end-all solution to the problem, because while 10 to 15% of the body's cholesterol comes from the diet, such as eating foods that are high in cholesterol, 85 to 90% of the body's cholesterol instead is synthesized by the liver. So simply by reducing the cholesterol intake in your diet, you could lower your cholesterol, certainly, but it's not going to, in all cases, result in the cholesterol falling to a normal level, because some people are just, you might say, cursed with bad genes, where their bodies synthesize a lot of cholesterol within the liver, even if they're eating a very clean, healthy diet. So you might be saying to yourself, well, if cholesterol is synthesized in the liver, what types of nutrients are incorporated into that? Could we limit those types of nutrients from our food and therefore limit the amount of synthesis of cholesterol by the liver? And the answer is not so much, because both carbohydrates and fats can be converted into cholesterol. Proteins are the only one that cannot be converted into cholesterol. And so it's not really possible to limit both carbohydrates and fats because those are necessary for a variety of other functions. And so as a result, in some cases, no matter how much a person carefully controls what they eat, they still need cholesterol-lowering drugs in order to cope with their high cholesterol levels. Statins are a commonly prescribed class of drug used to lower cholesterol levels. The way that statins work is keeping in mind that cholesterol is primarily synthesized within the liver through the action of enzymes that catalyze the reactions required to create cholesterol out of biomolecules from the decomposition of fats and carbohydrates. Statins work by blocking or inhibiting those liver enzymes from carrying out the reactions necessary to synthesize cholesterol, thereby lowering the overall levels of cholesterol within the bloodstream. When a patient sees their physician to have their lipid profile analyzed, typically in addition to the physician ordering a test of the total cholesterol, the physician also orders a test of HDL, which stands for high density lipoprotein, as well as LDL, which stands for low density lipoprotein. High-density lipoprotein is generally referred to as good cholesterol, as our post-it note indicates, whereas LDL, low-density lipoprotein, is referred to as bad cholesterol. Why the distinction between these two? Well, in the case of HDL, high-density lipoprotein, the chemical reason why it's referred to as high-density lipoprotein is it represents a structure where the cholesterol, the lipid, or the lipo part of the molecule, is complexed with a protein to allow it to be transported around the body, because due to the fact that cholesterol is quite nonpolar, it would otherwise not be effectively transported around the body. With high-density lipoprotein, there is a relatively high ratio of protein to lipid. Proteins are more dense than lipids, and as a consequence of that, high-density lipoprotein has a relatively high density compared to low-density lipoprotein, where there's a lower ratio of protein to lipid. In other words, there's proportionally more lipid relative to protein in an LDL. As a result, the density of LDL is lower, hence low density lipoprotein. So whether it's classified as high density or low density has to do with the relative amount of cholesterol compared to the amount of protein present. The reason why LDL is generally considered bad cholesterol and HDL as good cholesterol is because HDL is able to effectively enter cells and be metabolized. On the other hand, LDL instead is generally not as able to enter cells, and as a result can more readily accumulate in the bloodstream, which ultimately is believed to lead to plaque buildup within the arteries, due to the fact that these lipids, as they build up in the arteries, are not very water soluble overall, and hence cannot be washed away in the aqueous mixture of blood, hence leading to buildup and leading to problems long term. These problems include such things as heart attacks, strokes, and other cardiovascular ailments.